Brendan, Asher, and Julie share some money in the ratios of 3 to 2 to 6. So this means that Brendan gets 3 parts of the money, Asher gets 2 parts, and Julie gets 6. Now, the total amount of money that Asher and Julie receives, that is the last 2 parts by the way, is $36. Work out the amount of money that Brendan receives. Now, when you look at these kind of ratio problems, always look at the total amount and try and relate it to the ratios. And in this case, Asher and Julie represents the last 2 parts, right? It tells us that the total, in other words, both parts, so 2 plus 6, which is 8 parts, must be equal to the $36. So to get every single part, we should try and find one part. So this means that one part can be found if we divide 36 by 8. And if you do that, guys, you should get 4.5 or $4.50. So for Brendan, and we know that Brendan receives 3 parts, that means all we need to do is now multiply our result by 3. And when you do that, guys, you should get an amount of $13.50. And that's it. That's your one done. Now, for number 2, they want us to show that this multiplication equals the right-hand side. Now, as usual, guys, you cannot put this in your calculator straight away because you need to show some steps. Now, what I will do, guys, is always rewrite this in improper fraction. So to change 3 and 1/5 into improper fraction, I would multiply 3 with 5, which will give us 15, and add to the 1, and it will give us 16. So it will be 16 over 5. And for the second fraction, do the same thing. 2 times 8 is 16. 16 plus 5 is 21. So it's 21 over 8. So the way I would approach this is multiply these head on and write 16 times 21 in the calculator. And this should give us 336. And then 5 times 8, which is 40. Now I would put this in the calculator exactly as I see it, 336 over 40, and this will simplify automatically to 42 over 5. So no thinking required. And because you have literally one more step to go from here to the result, just write the answer directly and just write 8 2/5. And if you guys are not sure if there's anything you should write, you can put in bracket shown or something, just to be clear that you've reached the result. And yeah, that's 2 done. So for number 3, we need to make A the subject of D equals G plus 2AC. Okay, so to do this, guys, you have to first move every single variable that isn't touching A. So let's move G across. To move G across, we have to subtract it. So it'll be D minus G equals 2AC. And to separate the 2 and C from the A, because they're all multiplied, we need to divide them away. So dividing 2C, you're now going to get D minus G over 2C, and now you're just left with A. And that's the result, guys. So you can write it neatly as A equals D minus G over 2C. Now for part B, we got to factorize fully 9EF minus 12F. So to factorize, it just essentially means you got to divide both of these terms by common factors, yeah? Numbers and letters, by the way. So for the numbers, we can look at 9 and 12, and we can kind of see that they're both in the 3 times table. So this means we're going to whip out a 3 outside, some bracket. And now we look at the letters, well, they both have an F. So we can whip out F as well. And then we write a bracket like this. And we ask ourselves, okay, so what is 9EF divided by 3F? Well, 9 divided by 3 is 3. You still got an E. And F divided by F cancels out, so there's no F. Then you write a minus sign. Then we say, okay, 12 divided by 3 is 4. And F divided by F is gone. So this is your final result. Now for part C, they want us to expand and simplify that double bracket. So for these cases, you always do term by term when you multiply. So it's going to be x times x, x times minus 5, and then 2 times x, 2 times minus 5. So when you do that, x times x is x squared, x times minus 5 is minus 5x, 2 times x is plus 2x, and lastly, 2 times minus 5 is minus 10. And for these quadratics, you always have to try and simplify the middle terms, yeah? So this means that minus 5x plus 2x, if you just put minus 5 plus 2 in your calculator, you should get a minus 3x. And that means our final result is therefore x squared minus 3x minus 10. And lastly, for part D, I think that's the last one, yep. Simplify fully this fraction. Now, when you're multiplying terms that have powers like with the same bases like n, you just simply add the powers, yeah? So n to the 4 times n to the 7. If you add up 4 and 7, you get n to the 11. And you still got n to the 5 below. When you divide, you subtract the powers. So 11 take away 5 is going to give us n to the 6. And that's it, guys. That's 3 done. Okay, for number 4, we're given 3 different sets here. So we've got B for blues, and they use the letters BLUE. G is grey, GREY, and W is white, WHITE. Now, this question wants us to list all the members of the set where B unites with G. So this is a union sign, and this little bridge end sign is an intersection, so what they have in common. So for the uniting thing, we just write every single letter that they appear in both B and G. Well, if we look at both sets, they literally have a BLUE and a GREY. What you do, however, is you don't repeat the letters. So what I would do, I'll say, okay, the result is going to be a BLUE, and they also have a G, an R, but I'm not going to repeat the E, and a Y. So you just literally list every single letter in both sets. And for the second part, we need to find the members of the set which intersect between W and not G. Now, to understand not G, it's better to firstly work out what is the intersection between W and G to get a better understanding. Well, when we look at the intersection between both, we look at the common elements. So looking at the grey and the white, they both have the letter E. So this implies that the intersection between white and not G would be where it doesn't have. Well, it doesn't have a W, H, I, and T. So that would be your answer for part 2. It would be W, H, I, and T. Okay? Now, for the last part, it says Serena writes down the statement B intersecting with G, intersecting with W are all empty. In other words, there is nothing in common between them. Just looking at all the 3 sets, we find out that all of them have the letter E. So this is false. Okay? In fact, they all have an E. And that's it. We're done for number 4. Okay, question 5. So the diagram shows UN's garden. Now, this garden is in the shape of a semicircle radius 7.2 meters. Okay? Now, UN is going to cover his garden with grass seed. UN has 12 boxes of grass seed, and each box contains enough seed to cover about 6 meters squared of the garden. Well, does he have enough grass seed for his garden? Show your work in. Okay, so for these kind of questions, the most important element is to always find out firstly how big the garden is. So what is the area of the garden? Well, because we know it's a semicircle, this is essentially half the area of a circle. We need to remember that the area of a circle is pi r squared. Because we're dealing with the half the circle, we're going to divide the result by 2. We know that the radius is 7.2 meters, so we're just going to plug in 7.2 for r. So our area is actually going to be pi times 7.2 squared all over 2. Now, when you put this in a calculator, guys, you should get an area of about 81.43 meters squared. Now, we know that UN has 12 boxes of grass seed, and each of those boxes has enough seed to cover 6 meters. So that means 12 times 6 is actually 72 meters squared. So he could only cover 72 meters squared. Now, the question asked if this is enough. Well, it's actually not enough because he needs 81. So the answer would just be no, because 72 is way less than 81.43. Now for question 6, they want us to solve this quadratic equation which is set to 0 and show clear algebraic working. Now guys, this is just a straight up standard quadratic formula based question. All I recommend is that you guys use the quadratic formula. Now the quadratic formula looks a bit like this. We always say that x equals minus b plus minus the square root of b squared minus 4ac. And all of this is always over 2a. Now, what are these layers? Well, these layers a, b, c are actually the values in front of the x squared, the x, and the constant. So we say that, okay, a is 1, which is the value of the coefficient of x squared. B is going to be equal to minus 5, which is the coefficient of x. And c is the constant of minus 36. And all you guys have to do is literally plug these values into the formula. So you're going to get something like, well, minus b will end up becoming plus 5 plus minus the square root. B squared is minus 5 squared, which is 25, minus 4 times a, which is 1, times minus 36. Now all of this is over 2 times 1. Now, when you put this in your calculator, because you don't have a plus minus button in your calculators, you would first use the plus button. So replace plus minus with plus, and then you'll get a result of x equals 9. Or if you put a negative sign, you get a result of x equals minus 4. And these are your two answers, guys. And for 7, it says in a sale, the normal price of a hat is reduced by 15%. The sale price of the hat is 20.40 euros. Work out the normal price of the hat. Okay, for these questions, because you're dealing with price reduction and percentages, we always use this very nice formula we've been using for a while. And I call it the OV-NV formula. This tells us that first you have the original value, and it either increases or decreases by some rate, and you'll get a new value. Because we know that the normal price of a hat is reduced, we're going to use the negative sign. And R is going to be our 15%, and we know that the new price, i.e. the sale price, is 20.4. So our formula is now going to look like OV bracket 1 minus 15%. Well, 15% is the same as 0.15, and we know that the new value is now 20.40 euros. And all you literally have to do, guys, is just make OV the subject. And to do that, we just divide this bracket across. So you're going to have OV equals 20.40 over, well, 1 minus 0.15 is actually 0.85. And then put this in your calculator, guys, and you're going to get an actual normal price of 24 euros. And that's it. Okay, question 8. So 5 children are playing on a trampoline. Now the mean weight of the 5 children is 28 kg. So before we read on, this implies that because every single child is about 28 kg, this means that the total of 5 children is actually 5 times 28 kg. And doing that will give you a total weight of 140 kg for those 5 children. For the second part, it says 2 of the children get off the trampoline. Now the mean weight of these 2 children is 26.5. So again, because there's 2 of them and they average 26.5, if you double that, you're going to get a total weight of 53 kg for both children. Work out the mean weight of the 3 children who remain on trampoline. So in other words, the difference between these two. So if I had to subtract these two results, we'll find out that the weight of the 3 children was actually the difference between 140 and 53, which is 87 kg. Now if I had to divide that by 3, well, actually it turns out that the mean weight of each of those children, well, the 3 children that remain in trampoline, was 29 kg. And that's it, guys. That's this question done. Alright, number 9. Pablo made a solid gold statue. He melted down some gold blocks and used the gold to make the statue. Now each block of gold was a cuboid as shown below. Okay. Now the mass of the statue itself, made from these gold blocks, is 5.73 kg, but the density of the gold block above is 19.32 grams per centimeter cubed. Now they want us to work out the least number of gold blocks Pablo melted down in order to make the statue. So for this kind of question, we need to firstly calculate the volume of this gold block. So then that's something we can start with. So we can say that the volume of this gold block is just essentially all these 3 values multiplied. So 1.5 times 2 times 8, and that should give us 24 centimeters cubed. Now, they tell us that the density of gold is 19.32. So essentially, we can try and work out the mass of gold. Okay. Now, the density formula is something like density equals mass by volume. Because we're interested in finding the mass of the block, we can multiply the volume across. So essentially, volume times density would equal the mass. So that means we can say, alright, the mass of the block is essentially 24, which is the volume, times the density of gold. So 24 times 19.32. If you put that in your calculator, you should get a result of approximately 463.68 grams. Okay, so remember, we're working in grams here. Now, it tells us that the mass of the statue that he wants to melt the blocks and to form is actually 5.73 kg. So in grams, you got to multiply that by 1,000 to get 5,730 grams worth of blocks. So to work out the least number of gold blocks required, then you just have to divide these two values. So we can put in our calculator, okay, therefore he needs 5,730 divided by 463.68, and you're going to get some kind of decimal answer, something like 12.357. So the least number of blocks would have to be rounded up. So he'll need 13 blocks of gold. And that's it, guys. This question's done. Alright, number 10. So the diagram shows a regular hexagon and an isosceles triangle. So we got them both here. Now the perimeter of the hexagon is equal to the perimeter of the triangle. Find the length of each side of the hexagon. Okay, so one key thing to note, guys, because you've got a regular hexagon, this means that every single length around the hexagon is also x minus 1, so they're all the same. For an isosceles triangle, this tells us that two lengths are the same, and that's the one indicated by this little line here. So if the right hand side is x plus 5, then the left side is also x plus 5. Now, because the perimeter of the entire hexagon is equal to the triangle, we just have to firstly add up the perimeters of each shape and then equate them to each other. So for the hexagon, you got 6 sides and they're all worth x minus 1. That's literally just 6 times x minus 1. And that's going to equal the right hand side, which is x plus 5 plus x plus 5. That gives us 2x plus 10. And we also have another plus 2x minus 3. Plus 2x minus 3. Now, all we got to do here, guys, is literally expand the left side. So you're going to get 6x minus 6. And then collect like terms on the right, which is 4x plus 7. And then we just solve for x. So to solve for x here, I would firstly have to move all the x terms on one side and the non-x terms to the other. So let's shift 4x to the left. And to do that, we need to subtract 4x. So we're going to be left with 6x take away 4x, which is 2x. And we're going to have to add 6 across. If it's minus 6, if you move to the other side, you need to add 6. And 7 plus 6 is 13. And therefore, guys, to find the value x, you just have to half it. And half of 13 is going to be 6.5. And yeah, guys, we're almost done. And it says here to find the length of each side of a hexagon. Well, we know it's x minus 1. So wherever x is, which is 6.5, it'll be 1 less. So it's going to be 5.5. So that's your answer, guys. 5.5. Okay, for 11, it says that the weight of a cat is 4.3 kg corrected 2 significant figures. That's actually the same weight as my cat. Now A, write down the upper bound of the weight of the cat, and B is also the lower bound. Now guys, to find any bounds, and this is a super easy method to do it, you always look at the very final figure that was rounded, which is 0.3, yeah? Now we have to ask ourselves, what kind of unit is that? Well, this is the tenths, and this can be represented by the 0.1s, okay? If it was 2 decimal places, then it would be 0.01, and so on. And to find bounds, you literally have to half this value, so always half it, which is going to give us 0.05, and then we add a minus to 4.3. So this means that for the upper bound, it will be 4.3 plus 0.05, and for the lower bound, it will be 4.3 minus 0.05. If you do both these calculations, guys, you're just going to get 4.35 and 4.25. And that's it. Now for the next bit, it says g equals e minus f. Now 17 has been rounded to the nearest integer, meaning we look at the very last figure, which is a 1. And we know that half of 1 is 0.5. And 9.4 has been rounded to 1 decimal place. Again, you look at the last figure, which is a tenth, so that's 0.1. And you half that and you get 0.05. Okay. Work out the upper bound for the value of g. So to find an upper bound and you got a difference, you can think of the upper bound being the biggest possible value or combination you can make from these two, right? And if you think about, if you're subtracting terms, if you're subtracting a big number from a really small number, you're going to get a big difference. But if you subtract from two big numbers, it's no different than subtracting from two small values or two similar values. So the point is you want to maximize e and minimize f. So essentially, the upper bound of g is basically the upper bound of e, the biggest value of e, minus the smallest possible value of f. And well, if you look at it this way, guys, yeah, the upper bound of e is going to be 17 plus 0.5, so we can put it here. 17 plus 0.5, that's the upper bound of e. And the lower bound for f will be 9.4 minus 0.05. And then when you compute it, you should get an answer of 8.15. And I think we are done. Okay, 12. So the cumulative frequency graph gives information about the waiting times in minutes of people with appointments at hospital A. Okay, so by 60 people recorded, this means that all 50 minutes have been accounted for. Now, the graph wants us to find an estimate for the median waiting time at hospital A. Now, a median means the middle value, and this works with the cumulative frequency. So if we know that there are 60 people, then this tells us that the median will be half of them, so it'll be the 30th person. So all we do is literally draw a straight line, and we hit this value here, and just to zoom in a bit, this is going to be about, what's that, 23, I guess, guys? So like, yeah, so 23-ish, isn't it? So this means that the median value was 23 minutes. Now, use the graph to find an estimate for the interquartile range of the waiting times. So interquartile is literally the upper quartile minus the lower quartile. And just like the median, we need to find like a fraction of it. So lower quartile means we need to find the first quarter. And well, that's basically 1/4 of 60 people. And in the calculator, that's actually 15, yeah? So we just mark 15, which is annoyingly between these values. So it should meet up around here. And again, zooming that in. And I'm just going to just put to the nearest value here. I think that's going to just be around here. So that looks like, well, 11, 12, here's 15. This must be a 17. So the lower quartile is 17. And then if I go up for the upper quartile, guys, the upper quartile is literally the third quarter, yeah? So 3/4 of 60. That's just 3 times bigger than the first quartile. So it's going to be the 45th person. So this is the upper quartile. So you got upper quartile, lower quartile, and the median. So the upper quartile, if you again stretch it across, it hits around here. So I think that's perfectly on the line, isn't it? And if it is, you just stretch it down, and it hits around the 29 mark. So therefore, guys, the interquartile range is the difference between 29 and 17. So Ryan, you're working out 29 minus 17. That should give us a 12. Yeah. At a different hospital, hospital B, the median waiting time is 28 minutes and the interquartile range for the waiting time is 19 minutes. Compare the waiting times at A with the waiting times at hospital B. Now, it's better if you guys just write up both of them down. So what I did, I just boxed them both so I can actually directly compare them. Now, when you compare the median IQR, it's better to compare them from an actual context. So in this case, we're dealing with hospitals, waiting times, and patients. So for the median, what I wrote here is that the median waiting times is greater at hospital B because 28 is bigger than 23. So technically, what that tells us is that the patients generally wait longer than those at hospital A. Makes sense because median deals with average waiting time. Now the IQR deals with spread. What I wrote there is that the IQR waiting times is also larger, so it's bigger by 7 minutes. So there appears to be more variation in the waiting times at this hospital rather than A's. But other than that, guys, this is it for the question. Alright, 13. Use algebra to show that 0.5 and then 7.2 is recurring equals 63 over 110. Okay, so when they say use algebra, they literally tell us to let x be that variable. So we can say, okay, let x equal 0.57272 and so on. So it's always better to let it recur a bit. Now the trick for these kind of questions is that you want to try and line up these values here in like powers of 10 or 100 and so on. So what I'm trying to say here is say, okay, so what I'm trying to say here, let's multiply both sides by 10. So this can tell us that 10x equals 5.7272. And we ask ourselves, are the numbers lined up yet? Well, they ain't because now you got 5 and 7, 7 and 2. So objective is to make them line up. So what I'll do, I'll multiply this by 10 again. So you get 100x equals 57.2727 ... And probably one more time, 1000x. And this will give us 572.7272. Now, looking at all the equations, I can definitely tell us that on the decimal part, 10x equation and 1000x lines up. Why? Because they both got 0.7272, 0.7272. Now, what we do here, guys, is that we basically want to subtract both equations. So subtract the 1000x equation from the 10x. If you do it, well, 1000x minus 10x gives us 990x, whereas 572 point all of that, well, the decimal points will cancel out. All of them will cancel out. And all you're going to basically subtract is 572 minus 5. And that should give us 567. And, well, to find x, you just divide 990 across. So this means that x is 567 over 990. And then essentially just simplify this fraction, or just put this in a calculator. You'll get 63 over 110. And that's it. Now for the next bit, it says given that y is a prime number, express 3 over 3 minus root y in the form of this expression. So the reason why they tell us y is prime, meaning that we can't actually break it down. Because when you've got prime numbers, you can't actually separate it any further. So how to get from this form to that form? Well, there's a trick. All you have to do here is do some process called rationalization. So notice how there's normal surds at the bottom. To get only surds at the top, you go times up and down by its opposite sign surd. So instead of 2 minus root y, it'll be 2 plus root y. So we say, okay, 3 over 2 minus root y has to be multiplied by 2 plus root y over 2 plus root y. The reason behind this is because when you times up and down by the same term, it's like multiplying by 1, so nothing really changes. Now, let's have a look. So we're going to go ahead and wrap these in a bracket because you're going to do it term by term. And also wrap this in a bracket. And this is literally going to be, well, on the top half, 3 times all of this. 3 times 2 is 6. And 3 times root y is 3 root y. Now as for the bottom, just multiply this out as if it was a double bracket. So you can do 2 times 2, which is 4. 2 times root y is just plus 2 root y. And then minus root y times 2 is minus 2 root y. And lastly, minus root y times root y. When you times 2 of the same surds, you get a whole version. So you're going to get a whole minus y. Okay, and now we go ahead and simplify this. Well, to simplify, we cancel common terms. 2 root y cancels with minus 2 root y. So you actually get 6 plus 3 root y over 4 minus y. And that's it. We can wrap it up from here. Okay, number 14. So A, B, and C are points on a circle with center O. Now angle ABC is 38, so this one over here. And they want us to work out the size of angle OAC. Okay, so to be clear, OAC is from O all the way to A and then A all the way to C. So actually this is a chord right here. And they want us to work out this angle here. So let's call it X. So the first thing I recommend us to do is to try and find the angle at O, yeah? And this is easy to find because it follows this property. It tells us that if you have an angle at the center of a circle, then it should be twice the value at its circumference. So it's always in this format, yeah? If you see a shape like this, then you know it's double that value there. So essentially, if this is 38, then this will be 2 times 38, which is 76. Now, another feature is that we have a chord AC. And one of the other properties is that if you start from the center and you draw a straight line down and you cut the chord, you always form a right angle triangle on both sides. And the nice thing about this is that this splits directly in the middle. So 76 for both is actually 38 for both sides. So both angles around it are 38 again. And now this is straightforward. X is essentially part of a right angle triangle. So you got 90 here, you got 38. And all of this adds up to 180. So that means X must be 52 degrees. And that's it, guys. So the diagram shows 2 right angle triangles, DEF and EFG. And we have to work out the length of EG. So we can just label this unknown length X. Give your answer correct to 3 significant figures. Okay, so with these 2 right angle triangles, you'll probably notice that there's only one given length. And the only way to work out this X if we find another length. Now, the only common length they both have is this line here, EF. So let's call this one Y for a second, yeah? Now, every time you have a right angle triangles and you have angles involved, always think of Sohcahtoa. So this is part of trigonometry, where S is the sine, C is the cos, and T is the tan. Now, what I also recommend is that we should always redraw the triangles we're working with. So let's redraw the first triangle, yeah? So from the first triangle, we have 40 degrees. We have a length of 12 and an unknown length of y. Now for this kind of problem, it's always important that you label the relevant sides, so the sides you're working with. Now, the long diagonal side is always a hypotenuse, so this is h. And the length next to the angle is the adjacent a. So we always ask ourselves, what part of Sohcahtoa has a and h? Well, looking at this, Ka has it, so it'll be CAH. So we use Ka. And well, C stands for cos. And to write this as an equation, this is essentially cos of the angle, which is cos 40, equals A over H. So A being Y, H being 12. And then to find the answer here, we just have to pretty much make Y the subject. And to do that, we go clear the fraction. So we go times 12 across. So essentially, Y is going to equal 12 times cos 40. And when you put this in a calculator, you should get a length of roughly 9.19 centimeters. Okay, so that's our y done. Now what we can do is redraw the second triangle and update the value of y. So redrawing it here, you're going to have 9.19 here, you got x here, you got a right angle there, and you got an angle of 28 on the corner. So from this one, again, label the appropriate sides. So next to the angle is the adjacent, so x is the adjacent, and opposite angle is the opposite, so O. And looking at this, we ask ourselves which one has O and A from Sohcahtoa. Well, this time Toa has it, so it's going to be TOA. T stands for tan, so it'll be tan of the angle equals O over A. O being 9.19 and A being x. Now the difference between this one is that you have to make x subject again, but because x is on the denominator, we have to multiply x across and divide tan 28. So it looks something like this. X equals 9.19 over tan 28. And then when you put this in a calculator, guys, you should get a nice simple answer of roughly, and they wanted to, what is it, 3 centimeter figures. It's going to be 17.3 centimeters. And that's it. That's this question done. So Steffi is going to play 1 game of tennis and 1 game of chess. The probability that she will win the game of tennis is 0.6. So we can write here a little note. Probability that she will win tennis is 0.6. So this means that the probability that she does not win tennis, so instead of saying lose, it's better to say not win because maybe drawing is involved. And that's going to be 0.4. Okay? And the reason behind this is because all probabilities must sum up to 1. Now the next one tells us the probability that she will win both games is 0.42. So what this means is that the probability that she will win tennis and also win at chess is 0.42. So what this also means, and we can separate this probability, is saying that the probability that she wins tennis the first round, then she wins chess is 0.42, and winning tennis is going to be, well, we already know what that is 0.6 times winning at chess is 0.42, and then just rearranging to find the probability that she wins chess. So you could just divide these two, and if you divide it, you'll find that probability of winning chess is actually 0.7 or 70. Okay, so that's good. And what that also means, guys, the probability that she does not win chess is going to be 0.30 or 0.3. So I feel like we got everything now. Now the question wants us to work out the probability that she will not win either game. Well, we have all the probabilities. The probability that she will not win tennis is 0.4, and the probability that she will not win chess is 0.3. So if we times both 0.4 with 0.3, the answer should be 0.12 or 0.12. And we're done. Okay, question 17. So the function f is such that fx equals x minus 4 all squared. Okay, so this is defined by fx. And they want us to find f1. In other words, replace the x value of 1. Well, if you just do that, f1 is just literally going to be 1 minus 4 squared. And if you put this in a calculator, you just get a straight answer of 9. So that's it. Now b, state the range of the function f. So to find the range, they essentially want us to see how the graph looks like and see what values of y it takes. So to plot this function, I'll just plot it like this. You got your x and you got y axes. We know for sure that because the function is x minus 4 squared, this means it hits at x equals 4 twice. So if it hits at some curve twice, it means it bounces. So suppose x equals 4 is here. This is going to be a quadratic bouncing off it like that. So as you can see, it hits on the axis, and the lowest value on the y-axis is 0, and the highest is, well, is infinity. So we say that the range of f, so the range of fx is greater than equal than 0. And that's it, because it starts from 0 and it goes all the way up. And lastly, for the next question, it says that the function g is such that gx equals 4 over x plus 3. Work out fg2. Okay, what this means is that you have a function g and it goes inside f. So that's how it works. The second layer goes inside the first. Now what they're trying to tell us is that you should find g2 first. Well, g2 it just means replace the x with 2. So f over 2 plus 3 is actually 4/5, which is 0.8 if you like. And now you're going to put this 0.8 into fx. So we can say, right, f 0.8 is going to be 0.8 minus 4 all squared, and this is going to give us a nice result of 10.24. And that's functions done for you. So the diagram shows the graph of y equals fx for x between minus 4 and 12. Alright, so this looks like a cubic graph, and they got a point P over there. Now the point P on the curve has x coordinate 2. So it has an x coordinate 2 and actually a y coordinate of, and if we zoom in carefully, we can see that 3 is up here and everything's going up in 0.2. So this should hit over here at 2.4. So the coordinate here is just 2 and 2.4. Now they want us to use the graph to find an estimate for the gradient of the curve at P. Okay, so when they ask you to find a gradient at a certain point, you literally need to get a ruler and try and draw a straight line which touches P at one point. So something like, well, not like that, but I've actually previously done it, and it looks a bit like this. So this is kind of what they want. So you get a ruler and you draw a straight line like that. And well, to calculate the gradient, you simply just pick 2 points. And what I chose is the one at P, which we said was 2 and 2.4. And you'll probably realize that you should get a y-intercept of roughly 3.6. Now you can use this as a coordinate, because if you know the y-intercept, then you know the coordinate for that would be 0, 3.6. So you can say the other coordinate would be 0 and 3.6. And well guys, the gradient is just literally the change in y over change in x. So m equals change in y over change in x. That's essentially the difference between the coordinates. So over here, the change in y is just basically 3.6 minus 2.4 over 0 take away 2. If you put this in the calculator carefully, guys, you should get an answer of minus 3 over 5 or minus 0.6. And now the second part actually follows on directly from the first part. It says, hence, find an equation of the tangent to the curve at P, give your answer in the form y equals mx plus c. Well, the tangent is just literally the equation of this straight line. And we know that the general form of an equation is always y equals mx plus c. We know what m is. M was just minus 0.6. We know what c is. C is the y-intercept, which is 3.6. So because you know what m is and you know what c is, then we can say that the equation is just simply y equals minus 0.6 x plus a y-intercept of 3.6. Now in the mark scheme, and I haven't got the mark scheme yet guys, it could be a bit different. Maybe they got 0.5 or 0.7. So this is just an estimate, yeah? And usually with estimates, it could be a range of answers because it depends how you draw your line. But it shouldn't be too far off these values. And finally, guys, it says here that the equation fx equals k. And by the way, fx equals k means that you hit fx with a constant. So let's say k could be, I don't know, fx equals 2. This is the same as saying y equals 2. So this is just a straight line that hits the y-axis. So something like this, a straight line. Now, what they're trying to say here, and let's just read the question. It says that this equation has exactly 2 different solutions. Use the graph to find 2 possible values of k. Now, 2 different solutions literally implies is that it cuts through 2 different parts of the curve. Well, if I just drew over here for a second, just as an example, you'll see it cuts at 3 points, so it can't be in the middle. Because you'll realize that almost everywhere it's 3 points. Now, when they say 2 points, the only possibility is if there's a turning point. Well, we can see that there's a turning point here. And if you drew a straight line there, you'll notice that it hits exactly once there, and it will hit here as well. So in fact, one of the possible lines for y would be y equals, and you can see that it hits at 3, yeah? So this is at y equals 3. And you'll notice that the other possibility is at the other side, the other turning point, which is from here. So if you draw another straight line here that cuts across, it'll go all the way across, and it hits, well, at y equals -1. So these are your two solutions. That's it, guys. And you can say k is going to be, well, 3 or -1. And that's it. All right, question 19. Okay, so they give us a histogram now. And it tells us that this histogram gives information about the heights of all year 11 students at school. All right, so you got your height between 140 to 190, and you got frequency density on the y-axis. And the area of each block would be the number of pupils or the frequency. Now, there are 160 students in year 11 with a height between 155 and 170. So that tells us that, well, 155 should be this margin here, and 170 is here. So essentially the area of these two blocks, this one and that one, has a total area of 160. Okay. Now work out the total number of students in year 11 at the school. Alright, so an easy way to do this, guys, and since we've got some information already, is to kind of try and figure out what a height would be, yeah? Because the main idea is to basically essentially work out the area of these blocks, equate it to 160, and then find what the height could be. So an easy way to do this, I'll say, let's just count in ones, yeah? So for every major line like here, this would be 1, 2, so I'll put this as 1, 2, 3, 4. And just to make it easy, just think of this as 4x, 3x, 2x, and just x, yeah? Now, if you work out the area of this block, you'll realize that you got a base of, well, the difference is 5, and a height of 4x. And, well, 5 times 4x will just give us 20x. So that's the area of this block. For the second block, or this block here, the width is 10, and the height is 2x. So it'll be 10 times 2x is also 20x. So that means the total area of this block and that block, which is 40x, is also equal to 160 students. That means if you do the quick math and divide by 40, you realize that x is just going to be 4. So that means that the value for every single major frequency density is 4. So I could just now update this. So just cross out this x. This is 4. This is 8. This is 12. And this is 16. And guys, like for the rest of this problem, you just basically now just work out the area of the rest of the blocks. So for example, this block over here has a width from 170 to 185. So that's a width of 15. So you got 15 times a height of, well, what's that? That's between 4 and 6. 4 and 8. So that's a height of 6. So in your calculator, you just write, okay, 15 times 6. Put that in your calculator and you get an actual area of 90. For the next block, it's 5 times, oh, that's annoying. So this height is actually a bit different. We know that the major line here, which is 2, and I think every single line is going up in 0.4. So in fact, the height is 2.4. So in your calculator, this area would be 5 times 2.4. And well, 5 times 2.4 is just basically 12. Now for the last block, and that's the first one, the width is between 140 to 155, which is 15. So the width is 15, so 15 times. And the height is now from here up to this line. To check carefully, we know here is 6. It's going up in 0.4, so that's 6.4, 6.8, 7.2. So 15 times 7.2. If you do that, you should get a result of 108. And yeah, guys, now all you do is literally just add them up, yeah. So we know that these two blocks are 20x. X is 4, meaning these two blocks are 20 times 4, which is 80 and 80. And so adding all these results, 108 plus 12 plus the two 80s and plus the 90, you should get a total number of students of 370 year 11s at the school. Alright, number 20. So the diagram shows a frustum of a cone and a sphere. Now the frustum is made by removing a small cone from a large cone, and the cones are similar. Okay, so this is very important to note. When they tell you two things are similar, all it implies is that the small cone which is taken off from the big cone are just proportionally different. So we can see that the height of the small cone is actually h, but the height of the big cone is just 2 times bigger, 2h. So what that told us, guys, is that if these two have a scale factor of 2 times in difference, that means if the radius for the big cone is r, that means for the smaller cone it will be half the size. So in fact, the radius of the small cone is actually half of r, which is r over 2. Now this could be helpful for solving the rest of the problem. Now we're given some facts. The height of the small cone is h, large cone is 2h, and so and so. We also know that the radius of the big sphere is r. And finally, given that the volume of the frustum is equal to the volume of the sphere, so the frustum is basically what happens when you remove a small cone from a big cone, they want us to find an expression for r in terms of h. Okay, so let's make some notes. They tell us that the volume of the frustum is actually equal to the volume of the sphere over here. So to work out the volume of a frustum is literally the difference between the volume of a small cone and the volume of a big cone. And the formula looks like this. So volume for cone is just basically 1/3 of pi r squared times the height. I'm going to use capital letters so we don't mix up the radiuses and the heights. And as for the volume for sphere, it's just literally 4/3 pi r cubed. Okay, so let's deal with the cone first, yeah? So we know that the small cone has a radius of r over 2 and a height of h, and a big cone has a radius of r and a height of 2h. Let's do that, yeah? So we can say, okay, the volume of a frustum is simply the volume of a big cone minus the volume of the small cone. So what this means, guys, is that the volume of the big cone is 1/3 pi r squared, and we know the height was 2h, minus, and the volume of the small cone is 1/3 pi. Instead of r squared, the radius is actually r over 2, so it'll be bracket r over 2 squared, and the height is just h. So simplifying this fully, guys, we can just expand the bracket. So 2 times 1/3 is just going to be 2/3 pi r squared h. And now what I would do here, guys, is that I would actually square the r and get r squared, and square the 2, you get 4. So it'll be r squared over 4. And in your calculator, you can write 3 times 4, which is 12. So it becomes 1 over 12 pi r squared h. And yeah. And here we can see that there's like terms, yeah? They all have pi r squared h. So in your calculator, just write 2/3 minus 12, and you should get 7 over 12 pi r squared h. And that's it, guys. That's literally your volume for frustum. And well, the volume of sphere is just the formula itself. So technically, the volume of sphere is just 4/3 pi r cubed. And now, according to the question, they told us that both of them are equal, right? So now we just equate this to the sphere. So we say, all right, 7 over 12 pi r squared h must equal 4/3 of pi r cubed. And now we just go ahead and cancel what we can. So what I'll do, guys, they both have a pi, so cancel that out. They both have at least 2 powers of r, so r squared goes, and this power 3 goes, so you're left with r to the power 1. And now the equation reduces to 7 over 12h equals 4/3 r. And now at this stage, they told us that they want to find the expression for r in terms of h. In other words, make r the subject. So in your calculator, it will look a bit like this. You can just write r equals 7/12 over 4/3, and then just stick a h there. It should reduce nicely to 7 over 16h. And yeah, and that's it, guys. This should be your result. Okay, 21. So the diagram shows the prism ABCDEF with cross-section triangle ABC. So that's the front face of this prism. Now they give us some information about this prism. We know that angle BEC is 40 degrees, so BEC. So that's basically from here to here and here all the way to C. So we can think of that one as 40 degrees. And they also tell us that angle ACB is obtuse. And what obtuse means is that it's an angle which is larger than 90 degrees. Okay, so angle A to C to B, and this part here is greater than 90 degrees. Okay, now for the next bit, it tells us that AC is 6 and CE is 13. Okay, so let's go ahead and update this prism. Now from A to C, we can just put a 6 centimeters here. From C to E, which is the diagonal length, is going to be 13. So that's quite useful. Finally, they tell us that the area of triangle ABC, so the front face, equals 22 centimeters squared. So what I'll do is I'll firstly just copy this triangle out, so just relabel it here. So you got 6 over here, you got an unknown angle here, which is obtuse, and we're going to call that x. And we know that the total area of the triangle is 22 centimeters squared. Now, one way to find the area of a triangle is to use the general formula. And the general formula for an area of a triangle is always half AB sine C. Now, we can think of AB as two lengths next to each other with an angle C between. So if I had to relabel this triangle, I could think of this triangle as A on the left, B on the right, and a big angle C in the middle. Okay, and now they want us to calculate the length of AB, and AB is just long horizontal length over here. So let's give this a letter and call it Y. And just a quick recap, we call this angle up here X, and we call this length CB as, well, we can just call it letter B, yeah, just to match this one here. And yeah guys, that's it. So all we need to do is basically calculate the letter B first from this triangle here, and then find out X, and then from X we can find out Y. So let's begin. So to begin this, I'm going to go ahead and redraw this rectangle here, because if we think about it, this is just a right angle triangle actually. If we look at it in a 2D perspective, and we can solve this using Sohcahtoa. So let's copy this right angle triangle for a second, yeah? We're going to have a triangle like this with a length of 13, an angle of 40 degrees, a right angle triangle, and we're trying to find the length of CB. So CB is going to be represented by this letter B. Now, to solve this easily, use Sohcahtoa. And according to Sohcahtoa, we just need to label the corresponding sides, yeah? So first things first, we can see that number 13 is the hypotenuse. And the hypotenuse is always the long diagonal side. And well, the length opposite angle is just called the opposite O. And that's all we need. We don't necessarily need to use the adjacent, which is over here, because we just need the two things that we're actually dealing with. Here we're dealing with an opposite and a hypotenuse. So anything that has O and H, that's going to be SO. Okay, and according to SO tells us that we have sine for S of the angles. A sine of 40 equals O being the opposite B, over the hypotenuse being 13. Now to find B, all we have to do is just rearrange to make B the subject. So I'm going to go ahead and multiply 13 across. So we're going to have 13 times sine 40, and that's going to give us our B. And if you put this in a calculator, you should get a B value of 8.356 ... Okay, so let's just leave it to 3 decimal places for now, yeah? So that's B done. So we can just update this value B and just call it, what is it, 8.356, yeah? 8.356. Okay, so that's one done. Now we're going to try and find angle X, yeah? So let's go ahead and update this triangle over here. So this B here we just said was 8.356. And if we recall from earlier, they told us that the area of triangle ABC, which is this triangle, is 22. So what we could do, we can just go ahead and update these values here with numbers and make it equal to 22. So let's do it, yeah? So we know that the area of a triangle is half AB sine C. So it's going to be half times, well, our A and B in this case would be 6 and 8.356. So it would be times 6 times 8.356. We don't know what angle is yet. That's what we're trying to find. So we're going to just leave it as sine X. And it's supposed to equal an area of 22. Okay. So that's basically all of this part now. So all we do here is just literally simplify this. I would go ahead and divide all of these numbers across to the other side. So it will look something like that. We'll end up with just sine X on the left, and we're going to have 22 on the right, all over half times 6 times 8.356. And to get X, all we go do is separate sin from X. And to do that, it's literally the sine inverse, yeah? So it's going to look something like that. It'll be X equals the sine inverse of your whole fraction, yeah, so that whole fraction on the right side, and wherever this answer is in your calculus. So if you just smash 22 big fraction over half times 6 times 8.356, you'll get some kind of small decimal like 0.8ish, and if you sine inverse your answer, you'll get an actual degrees answer of 61.35 ... degrees. However guys, this is not the final answer, because they told us earlier that the angle ACB was obtuse. In other words, X is obtuse. And if it's obtuse, it means it has to be bigger than 90. So at the moment, it's currently in acute form. Now to change it to obtuse, all you got to do is literally subtract it from 180. So we can say, okay, 180 minus 61.35 should give us about 118.65 degrees. Now this is the right one. This is the obtuse angle we need. So at this stage, guys, we're not actually done yet because we still have one more bit left, and that's to find the length of AB. In other words, find what y is. And because we've got 3 lengths and 1 angle, we have to use the cosine rule. Now, thankfully, we're given the cosine rule formula, and if you guys are not sure, it looks like this. We say that we have an a squared which equals a b squared plus c squared minus 2bc cos of the angle A. And you can see here that this only has one capital A, so this is the only angle here, whereas A, B, C are lengths. And this corresponds perfectly to this triangle. You can imagine that the only angle is here, the big A, which is 118. That means this corresponding length must be little a, which is y, so that's y squared. And that means B and C could be either 6 or 8.356. So let's put all those values in here. So we're going to choose B as 6, so it'll be 6 squared plus 8.356 squared minus 2 times 6 times 8.356 times cos 118.6 degrees. And yeah, so let's pop all of this in the calculator. So if you put 6 squared plus all of this in the calculator, you should get a result of 153.822 ... However, this is the answer of y squared, and we just care about y. So just go ahead and square root your answer, yeah? And then when you do that, you should get a final result of approximately 12.4 centimeters. Alright, number 22. So we got the graph of y equals a cos x plus b, which is drawn on the grid. And here is our grid over here and our cos graph over here. And according to the question, they want us to find the value of a and the value of b. Okay, so before we try and figure out what this a and b represents, we need to first be familiar with a cos graph here. So for a cos graph, it looks a bit like this, yeah? So imagine we got just some random axes here, so I'm just going to go ahead and sketch it. So we got something like that. So this is just a random one. Let's just cut it through here, for instance, yeah? And it always looks like a bucket, so it always sweeps down, goes up, and then ends over here. So this could be some kind of bucket. We could say that the maximum value of a cos is 1, and the minimum value is -1. And the unique feature about these cos graphs is that every single point it hits, like at the peak and the bottom, it goes up in 90s, yeah? So we can imagine that along the x-axis, we've got 90 degrees here, then the next one is 180, and the next one is 270, and lastly is 360. Now, to figure out basically what this A and B is, we just got to ask ourselves, okay, what happens between each one? Well, you can kind of see that instead of starting at, let's say, 0 degrees, the peak starts at 60. So essentially, this is shifted by 60 degrees to the right. Now, this B deals with shift, yeah? So this x plus B means it's shifted a certain direction. If we're going to say shifted 60 degrees to the right, we're going to have to write x minus 60. Okay, not plus 60. If you wrote plus 60, it means you shifted to the left. So you've got to kind of think of the inside of where the x is as being done in reverse. So instantly, this means the B value will be minus 60. Now, the A in front of the cos means how much is being scaled up by. Well, again, looking at this graph and this graph, we can imagine that the highest value is 1. Well, according to this graph, the maximum value seems to be here, which is actually 2.5. And the minimum value, again, is minus 2.5. So actually, this means that A is just 2.5. That's it, guys. We can say that the value A is 2.5, and the value B is minus 60. And that's it. Now for the next bit, it says that another curve C has equation y equals fx. Now the coordinates of the minimum point of C are 4, 5. So you can kind of think of, let's say, we don't know what the graph looks like, but we can imagine it looks a bit like, let's say that. And this is your minimum point. It's 4, 5. Now write down the coordinates of the minimum point of the curve with equation y equals f 2 times x. Okay, so this is the same function. All it's saying here, compared to the original one, is that for all the x values, we now got 2x. But what this really means is that we should now half our x coordinates. So instead of 4, we're going to now have 2. And then the y coordinate stays the same. So it'll be 2, 5. Now for the second part, it says y equals fx minus 7. So notice how this minus 7 is outside the function. This means that this is a shift in the y-axis. Now if it said plus 7, this means you add 7 to your y coordinate. But because it's minus 7, means you got to subtract 7 from 5. So 5 take away 7 is minus 2. And of course, 4 stays the same. And that's it, guys. This is literally your corners done. So a particle moves along a straight line. The fixed point O lies on this line. Now the displacement of the particle from O at time t seconds, where t is positive, is s meters. So basically, they're going to use s as the displacement, and it's given by this cubic equation. Now at time big T seconds, the velocity of p is v meters per second, where v is big and equal to minus 5. Find the expression for t in terms of v, give your expression in this kind of weird looking surd form. Okay, let's do this, guys. Now, for these kind of questions, every time you got displacement, velocity, and even acceleration involved, so in other words, you got s, v, and a, you're essentially going to use differentiation, guys. So let's do this, guys. So let's go ahead and differentiate the displacement equation to get velocity. So we can say, all right, v equals ds over dt, and when you differentiate, you simply just drop the power down and subtract it by 1. So 3 goes down, so it becomes 3t. And subtracting the power by 1, you get 2, so 3t squared. Repeat the next step, drop the power down, so you get 4 times 2, which is 8, so plus 8t to the power 1. If you're just left with a t of no power, the t vanishes, so you got minus 5. And if you got a constant, that disappears, because there's no t associated with it. And that's it, guys. So you got a velocity expression of this. So you probably noticed that your result kind of resembles a quadratic equation, but this is an expression for t. So we're trying to solve in terms of t. Because you got a kind of a quadratic, but it doesn't equal 0, all you have to do, guys, is subtract v across. So if I rewrote this equation, we now have 3t squared plus 8t minus 5 equals v. And if I subtract v, you got 3t squared plus 8t minus 5 minus v equals 0. Now, to solve this easily, I'll just go ahead and use a quadratic formula. So the quadratic formula is a bit like this. We say, all right, t has to equal minus b plus minus the square root of b squared minus 4ac all over 2a. And just to recap, a is just simply the coefficient of t squared, so a is 3, b is going to be your 8, so it's these two values, and c is going to be all of this. So c equals minus 5 minus v. So now all we're going to do, guys, is just substitute all these variables into this equation and see what happens. So doing that, guys, you got minus b, so it'll be minus 8 plus minus the square root of, well, 8 squared is going to be 64 minus, now you got 4 times a, so 4 times a is 4 times 3 is 12, so it'll be minus 12 times your c, which is minus 5 minus v. We're going to get to that in a second, all over 2 times a. Well, 2 times 3 is 6. So far I think we're nearly there. We're actually nearly there. Now let's go ahead and tidy up the square root sign for a second, yeah? So I'm going to just work outside. So just pulling all of this bit outside, we got 64 minus 12 times minus 5 minus v. Just expanding the bracket, you can get 64 minus 12 times minus 5, which is plus 60. And then minus 12 times minus v is plus 12v. Okay, so that actually went quite good. And tidying this up, 64 plus 60 is actually 124 plus 12v equals minus 8 plus minus the square root of 124 plus 12v over 6. So let's see, what can we factorize here? Well, they go into a 2 times table, and they actually go into the 4 times table. So we can factorize a 4 out, and you're left with 31 plus 3v. Perfect. So what we could do, we can update these values here, and you'll notice that you're going to have now the square root of 4 times 31 plus 3v. Now what you could do here is actually separate this. This is the same as the square root of 4 times the square root of everything in the bracket. Well, we know that the square root of 4 is just 2. So this is just simply minus 8 plus minus 2 times the square root of that bracket, 31 plus 3v over 6. And finally, guys, on the top line, we can actually factorize the 2. So it'll be something like this. It'll be, well, take 2 out, and you got minus 4 plus minus, and that becomes 1. So it'll be square root of 31 plus 3v all over 6. And actually, if you cancel the 2 and the 6, 2 and 6 breaks down to 1 and 3. And yeah, guys, that's actually the final answer. The final answer is essentially, well, that's gone, that's gone. You don't need brackets. It's just minus 4 plus minus all of that over 3. And yeah, that's it. We got the answer. So we can say, therefore, capital T is just minus 4 plus minus square root of 31 plus 3 capital V over 3. And that's it. We're done. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications, and if you want, you can do personalize or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.